Good morning, afternoon, or evening. How y'all doing today? Welcome back to Morrow's Math Corner. Today we're going to learn how to work with and solve quadratic inequalities. Now there are two ways of solving quadratic inequalities. The first one is graphically, and the second one is algebraically. Today we will learn how to solve quadratic inequalities algebraically, and I'll explain why after this first example. So let's get right to it. Let's solve x squared minus 4x minus 5 is greater than or equal to 0. Well, first things first, step one, we're going to go ahead and write the inequality in standard form and set it equal to 0. Remember that standard form is ax squared plus bx plus c equals 0. Once it's in standard form, we're going to go ahead and solve the equation. Well, we have a lot of choices now, a lot of tools that we can use for solving. If there's no bx term, we can use the square root method. If there is a bx term, then we can either factor and use the zero product property, complete the square, or when in doubt, use the quadratic formula. But I'm going to go ahead and try to factor this first. So I'm going to go ahead and ask myself, what times what is negative 5, but when added together is negative 4. And I've got x minus 5 times x plus 1. We're going to go ahead and use the zero product property to go ahead and render the solutions, which is that x equals 5 and negative 1. So we went ahead and did step 2 as well here, solve the equation. Now, step 3. We're going to go ahead and plot the solutions on a real number line and test each interval in order to find the sign, whether it's plus or minus, of your original inequalities. Please remember that a negative times a negative is a positive times a positive is a positive, a negative times a positive is a negative, and a positive times a negative is a negative. So we know that the solutions are 5 and negative 1. So we're going to draw a little number line here. We're going to put our negative 1 and 5. We know that it's greater than or equal to, so these are going to be solid circles here. If it was just greater than or less than, it'd be open circles. And now my test zones. My solutions can either be less than or equal to negative 1, that's test zone 1. In between negative 1 and 5, that's test zone 2, or greater than or equal to 5, which is test zone 3. Now you can choose a value from either test zone. It does not matter. But here's the kicker. If test zone 1 works, then test zone 3 works, and test zone 2 does not work. Vice versa. If test zone 3 works, then 1 works and 2 does not work. And of course, you probably figured this out already. If zone 2 works, then zone 1 and 3 does not work. So based on that, I like to choose values from the test zone that is easiest for me. And in this particular case, it's going to be from test zone 2, and I'm going to use the value of 0. And I'm literally going to plug that value of 0 for all the x's. So I have x minus 5, which is negative 5, times 0 plus 1 is 1, and that is negative 5, but negative 5 is not greater than or equal to 0. So test zone 2 does not work, so that means test zone 1 and 3 works. So that means that my solutions are from negative infinity to negative 1 in union with 5 to infinity. And now, if you wanted to graph it, now would be the time to graph it. So, how would you do so? Your first things first is your axis of symmetry is x equals negative b, which in this case would be 4 over 2a. So x would equal 2. That's my axis of symmetry. 2, my vertex. My vertex, the x value of 2 when I plug it in, 2 squared is 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. That's my vertex. And then my y-intercept is when x is 0, y is negative 5. And I have my x-intercepts, actually. Here for step 4, My x-intercepts here are x equals -1 or 5. And now I know how to shade it as well. So now, if I were to go ahead and graph this, I'm just going to go ahead and do a relatively quick graph here, just so you could see what's going on. Okay, so my axis of symmetry is x equals 2. So I'm going to go ahead and graph that dashed line going 2. And then we've got 2, -9 is my vertex. So 2, -9 is my vertex. My y-intercept is 0, -5. So I got 1, 2, 3, 4, 5. That's 1, 2 to the left. So go 1, 2 to the right for my mirror image. And then I've got -1 as a 0, and then 1, 2, 3, 4, 5 as a 0. And it's a solid line because it's greater than or equal to. And we know that my solutions are from -infinity to -1, and then 5 to infinity. So that means that it's the outside of the graph. And that's why solving it algebraically is so important. This way you know how to shade, and there's no guessing. And there you have it. All right, so let's do some more examples. We're just going to go ahead and solve these, not graph them. So first things first, I always like to make everything easy for me to read. So I like to read from left to right. And so therefore, I'm going to go ahead and subtract 3x to both sides. So I've got -x squared plus 10, actually, minus 3x, sorry about that, plus 10 is greater than 0. I'm going to go ahead and get rid of that -1 because I always want a leading coefficient that's positive. So I've got x squared plus 3x minus 10 is actually less than 0 because whenever you divide by a negative, you flip the inequality. So now what times what is -10, but when added together is 3. We've got a -2 and a positive 5. So my zeros are x equals 2 and -5. I'm going to go ahead and pop that onto the number line, get my test zones. This is going to be open circles because it's greater than. So I can go to the left, it's less than -5, that's test zone 1. In between -5 and 2, that's test zone 2. And to the right, greater than 2 is test zone 3. I'm a creature of habit, so I'm going to choose a value from test zone 2, and that value I'm going to use is 0 for the x. So 0 minus 2 is -2. 0 plus 5 is 5. -2 times 5 is -10. -10 is less than 0, so it works. So test zone 1 and test zone 3 do not work, but test zone 2 does work. So my solutions here would be from -5 to 2, and those are parentheses because it's greater than, not greater than or equal to. Next, for B, I'm going to go ahead and keep everything on the left here again. So I'm going to go ahead and subtract 2x and add 24, subtract 2x and add 24. So I've got -x squared minus 2x plus 24 is less than 0. I'm going to go ahead and divide everything by a -1 to get my leading coefficient positive, and that will render me with x squared plus 2x minus 24 is less than 0. I'm going to go ahead and factor this. It's going to be x plus 6 and x minus 4, because 6 times -4 is -24, and 6 minus 4 is positive 2. My zeros are x equals -6 and positive 4. So I'm going to go ahead and create my number line here with my -6 and my 4. This is open circle because x squared plus 2x minus 24 is less than 0, so it's open circles. So I can go less than -6, that's test zone 1. In between -6 and 4, that's test zone 2. And then greater than 4 is test zone 3. Once again, I'm going to choose a value from test zone 2, and that value I'm going to choose is 0. So 0 plus 6 is 6, times 0 minus 4 is negative 4. So that's negative 24, which is less than 0. So test zone 2 does work. Test zone 1 and 3 do not work. So my solution here is between negative 6 and 4. Okay. Next, I'm going to go ahead and subtract 7 to both sides. I've got 2x squared plus 5x minus 7 is less than 0. Remember, if this stresses you out, you could use a quadratic formula if needed. But this particular case, I'm going to go ahead and try to use the Cuban method. So I've got 2x and 2x. 2 times negative 7 is negative 14. What times what is negative 14? But when added together is positive 5. You got positive 7 and negative 2. I'm going to go ahead and imaginary factor that 2. So I've got 2x plus 7 times x minus 2 is less than 0. So my zeros are x is equal to negative 7 halves and also positive 1. Going to go ahead and make my number line here. This is open circles once again. So I can be less than negative 7 halves, that's test zone 1. In between negative 7 halves and 1, that's test zone 2. And greater than 1, that's test zone 3. Once again, creature of habit, I'm going to use my test zone 2 here. I'm going to use a 0. And 0 plus 7 is 7. 0 minus 1 is negative 1. That's negative 7, which is less than 0. So yes, 2 works. That means test zone 1 and 3 do not work. So my solution is between negative 7 halves, parentheses, and 1 with parentheses. And last but not least, okay, remember that when we have 4 terms, we're going to go ahead and use the grouping method of factoring. So we're going to go ahead and group these two. We're going to factor out a common factor of m squared here, leaving me with m plus 1. And then from here, I'm going to go ahead and factor out a negative 9. If I factor out a negative 9, I'm left with the exact identical binomial of m plus 1. Now I'm going to go ahead and factor the m plus 1, which is the common factor here. And I have a leftover of m squared minus 9. Please note that that is a difference of squares. So this is m plus 1 times m plus 3 times m minus 3 is less than or equal to 0. Using the zero product property, m will equal negative 1, negative 3, and positive 3. Now I have 3 zeros, so that means I'm going to have actually 4 test zones. Got negative 3, negative 1, and positive 3. So I can, and this is less than or equal to, so these are all solid circles because they are included. So I can be less than or equal to negative 3, that's test zone 1. Between negative 3 and negative 1, that's test zone 2. Between negative 1 and 3, that's test zone 3. And greater than or equal to 3, which is test zone 4. I'm going to go to the easiest value, so I'm going to choose 0 from test zone 3. When I choose 0, 0 plus 1 is 1. 0 plus 3 is 3. 0 minus 3 is negative 3. So that's negative 9. Negative 9 is less than or equal to 3. So that means that 3 works. If 3 works, 1 works, and that means 2 and 4 do not work. So my solution would be from negative infinity to negative 3, bracket, in union with bracket negative 1 to positive 3. And those would be my solutions. Thank you so very much for watching. Hope you learned a lot. Come back anytime. Take care now. Bye-bye.